Good afternoon. Thank you for our colleagues. And I anticipate, I apologize for my Spanish, half Spanish, half Portuguese, and I will make myself understood by all of you, so I apologize for my accent. Now, to begin, my name is Paulo Alvarenga. I am the CEO for ThyssenKrupp for South America. And a short background, we are a German group. The last fiscal year, we had an order intake of 44 billion euros, a sales of 41 billion, and an adjusted EBIT of 2 billion, and many employees. We have 180 years history. We began our experience in South America and Brazil, and we have been in all the South American countries. In the last years, we have changed the structure of the group. We have sold a portion of our portfolio. We have quite a bit of history in the area. Our presence in South America is an invoicing of 905 million, 3.7 thousand employees, 9 industrial plants. We had 2 plants until September in Chile. In mining, we have sold that operation. So today we do not have a presence in Chile any longer, but I'm sure that soon, considering the green hydrogen, we will soon be back. In Brazil, we have a very important position. We are in 9 out of 10 vehicles that are manufactured in Brazil have ThyssenKrupp equipment. We have the most modern and innovative naval projects. We have 4 frigates class, and so we have components for engineering solutions for the decarbonization. We're going to talk about various topics in this field. Let me tell you about some of the fields. Some colleagues have already stated it. It's important to remember that the most important advantage of green hydrogen comes due to climate change, right? And no matter what we say that we have to close or we have to go to the net zero to 2050, or as has been agreed in the Paris Agreement 2015 to date, we are still issuing more and more emissions. We have yet not reached the peak of this curve until we begin to change this direction. This is a very dangerous trend. It's like a high speeding car and there is a wall, and instead of braking, we are accelerating. And in order to reach net zero, we require 4 major elements. There are others that are smaller in complexity, is industry, the primary energy, electricity, mobility, and we talk cars, trucks, buses, shipments, carriers, and planes, and agro industry with GHG issues. So we estimate that by 2050, there's going to be $275 trillion. I cannot count the amount of zeros. That is how big the need is. I want to put this in a more tangible manner. According to H2 Council, the World Organization linked to hydrogen, it is estimated that to reach the Paris Agreement indexes, we would need to have 20% of the entire global energy in green. If we find the equivalent in electrolysis, we would need to implement by 2050 5,500 gigawatts. And it's an enormous amount of energy. If we consider just as a power factor of 50% for renewables, solar and wind, we would need 11,000 gigabytes of renewable energy, new energy in the world in order to reach that number. If we change, if we compare it, for example, with the Itaipu plant that we have in South America, the largest plants in the world in this area with water resources. We need 600 new Itaipu plants of renewable energy in order to reach that figure. If we compare it to Chile, as was presented this morning, the Chilean installed capacity is about 30 gigawatts. We need to do 360 times the Chilean installed capacity in the world in the next 30 years, 12 times Chile per year, every year for the next 30 years. It's an effort that has not been seen to date beyond war times. It's never been seen in the world in times of peace, let's say. It is a battle. Um, it is a challenge, but there are indications towards solutions. If we look at the main use of hydrogen, we have three main industrial application: refining, the ammonia production, and steel manufacturing. If we had monetizing mechanisms that are effective worldwide, from $50 on the cost of carbon cost would be comparable and competitive to produce green steel. But this says from the operational, the OPEX, which is not calculated here, is that today plants, they're already installed. CapEx, which was invested, has already been done. And so conversions is different. But from the operational standpoint, at this cost, carbon cost level, which is real, at least in Europe, we can have a competitive operation with green hydrogen. That is one, the major challenge is in the capex. Now, what I'm trying to say is that the economy of scale in the use of green hydrogen to to be adopted, let's say, the challenges that are existing in current plants and the investment in hydrolysis, and as colleagues stated recently, the transformation and transportation on the long term, whether pipelines or the conversion for ammonia or methanol, which are other energy production for the manufacturing of these chemical products, it is very important to understand that there has to be a scale so that unit prices can drop. Now, I want to show you a concept of what we have developed as far as green hydrogen is concerned. We have a plant that has 20 megawatts. It is the smallest that we offer today. We have more than 600 electrolysis projects worldwide. The technologies of electrolysis was not developed further because of competitiveness, but it existed and we developed it 60 years ago. Now we have the capacity to execute projects to a size of 1 gigawatts a year, and we expect to reach 5 gigawatts by year 2025. When we compare available technology today with green hydrogen, in our opinion, we believe that there are three technological areas which are alkaline water electrolysis, polymer, and SOEC, solid oxide electrolyzer cell. The harder one based on all the experience is the technology that is the alkaline water electrolysis. It is the most mature, it's ready for commercial scale. It has more maturity to scale also. As I said before, to do 30 or 20 times for the of Chile in the next decades, we need to scale things. It is the technology that is most adapted. It is alkaline water electrolysis. I don't believe, however, that it's going to this it's not one technology over another. It's a development of specific applications for different scales based on the application, if it's for local consumption, for transportation, or for large scale, long distance transportation. So it will scale up depending on the technology that is required. In our opinion, for large applications, large volumes, for long-term distance carrier electrolysis, alkaline water electrolysis is going to be the most adequate. Now, if we observe as far as costs are concerned, what the market considers is the mean investment and the PEM cost evolution, we can see that the major difference today, sorry, is it is very important that AWE requires noble minerals,
que la PEM. Entonces,
but less requirements than PEM. But technology works, but with a effectiveness that is much lower. So PEM requires the minerals. So there's an advantage for this technology when we talk about large scale. What we can understand by the technology that's available today, there is a optimization focus. Approximately 4 to 5 years, it will be necessary to implement a new technology that will be more disruptive, where we can increase a current involvement so that we can increase the size of the plants and the capacity of plants, which will allow it to scale. Now, I have cut out, so there's a great deal of studies on this, and I'm always asked, well, what do I see about the countries? And at the end of the day, I see that there's a great deal of discussion based on details. We see a publication by Bloomberg NEF, which shows Latin America as the first three rankings, which are South American countries. And for me, electricity, one, two, or three, is that Latin America is one of the most competitive areas in the world. And it's not going to be one over the other. One is the major player of the other because the demand is gigantic. And consumers, under examples of what happened between Germany and Russia, it's a geopolitical situation. Nobody's going to concentrate their energy on one or other country. So all the countries that will be potential exporters is that everybody has a relationship with all the consumers, although with different intensity. It will depend on their logistics or other geopolitical factor. The good news is in South America, given all the decisions, we are well positioned to be a champion area. Now, given the evolution of the last years, in 2018, we began our operations in a demonstration plant within our iron producing, it's called ThyssenKrupp Nucera. We developed technology not only for the use of green hydrogen within our manufacturing plant, but also for the development and capturing of carbon, capturing development. In this demo facility, we generate green hydrogen, as we have seen in the first presentation on the panel. After that, we were able to do green steel, but there is still CO2. And with that, with the green hydrogen and the union of nitrogen. As we all know, we generate green hydrogen, and with CO2 that is in the chimneys of steel plants, we can create green urea. And so this is a comprehensive, which is proved on scale how these applications can be utilized. In 2021, we have projects in the United States. What's most emblematic here is NEOM in Saudi Arabia in 2.2 gigawatts of electrolysis plant. In a modular plant, we're talking about 110 modular plants together. This is the most emblematic construction of green hydrogen in the world. At Shell in Netherlands, we have other projects in the United States, and in the middle of last year, Unigel, which is a Brazilian client that produces ammonia of 60 megawatt plant. This is Unigel plant. This is the first plant at the industrial scale in Brazil. The takeoff of the plant will be at the end of 2023. When when it becomes operational, it's going to be the largest production of green ammonia in the world. In 2025, we have other plants that are soon going to be prepared, and with that, they are going to go one after the other. The operations of this Unigel plant will be the largest green ammonia plant in the world. We have signed an agreement with Unigel to expand the production to 60 to 140 megawatts after 2025. But the first phase after this year, in 2025, it's going to be 140 megabytes. And the crucial aspect that we have been referring to is what are we missing to develop, jumpstart the hydrogen economy? What is it we need? We're always talking about off-takers, and we need the applications and so on. The world's economy has always developed with an economic logic. And today, the reality, for a purely economic reason, green hydrogen is not the economic path compared to other energies. It's important to state that there's going to be an advantage. Climate catastrophes are going to be so disastrous that the repair is going to be much higher than changing energy, but it will be too late. From our standpoint, it is fundamental that we have a political standpoint in order to implement industrial policy making that will mobilize and motivate the migration. This morning we heard how the blend of green hydrogen with natural gas. This is a perfect example of how, through regulation, governments can motivate the local markets or domestic markets. It's very difficult to imagine an industry. Look what's happened in the United States. We were discussing this in Europe, the best mechanism, the perfect strategy to develop the market. The United States are giving an incentive up to $3 per green hydrogen. That's it. The project that we're discussing in South America, we wait. Let's start by the United States. If governments in South America, including Chile, Brazil, Argentina, if we don't react quickly, we might lose it. We might lose the opportunity, the window of opportunity, because there's in America in 5 to 10 years, we don't know what the market's going to look like. Right now, public policies, industrial public policies, so that we will create domestic markets to create a baseline for exports. Now, the clear cost and availability of renewable energy, given the dimensions and the challenges, the amount of energy, the cost is fundamental. Approximately 60 to 65% of the green hydrogen cost comes from renewable energy. The cost, the capex costs, or the electrolysis plant and so on, is about 20 to 25%. It's still significant, but if it goes down from current prices to half, we can bring it down to 20, 25% to 10, 12. So the final product will go to 100 to 80, 88, but the renewable energy cost is two-thirds, 65%. And finally, a scale issue. Scale, scale, scale. If you don't make it scalable, the prices of equipment needs to be scaled. If we reach the facility at the world level of approximately 40 gigabytes of electrolysis, the prices, the final cost of green hydrogen is going to be competitive like today. And this could take place at the end of the decade. Just to give you an idea, we'll go back to the first point, regulation and in the public policy. Thank you very much for your attention. That's what I wanted to say.